Hey there, welcome back to CMTEQ channel. So we're going to quickly dive into the Azoteq IQS9320. Shouldn't be very long, but trust me, it's going to be a few worthwhile minutes because you're going to find out about this amazing integrated circuit from Azoteq Semiconductor. The IQS93 ProxFusion IC is a flexible multi-channel inductive sensor device that has up to 20 inductive sensors, right? Channels that you can actually interface from a single IC. So it has adjustable actuation points, analog data streaming, and high report rate. So this thing is very accurate. Now, you can do quite a lot with this. Look at the frequency. The sampling rate is up to 1 kilohertz. Amazing for your embedded system application. There is RF immunity and the communication interface, I2C. You can use it with any microcontroller that support I2C. Now, the packages, like this is a QFN package and comes with many other packages. Now, application, mechanical keyboards, like this keyboard here, waterproof buttons, remote control gaming controllers. Now, these are robots application. This is why inductive sensors are basically taking over from capacitive sensors that we've been accustomed to over the years. The reference schematic here is very simple. Just the controller with your interface to communicate, like we'll see when we're going to connect this into this module here. This is just basically an EV kit interface to test this evaluation kit here. Okay, so inside here, there is an embedded system device, a microcontroller, right? Why? Because there is a display. Whenever you see a display with buttons, just believe you me, there is a controller in there. So the controller in there is going to communicate with the IQS9320 device that is on this module, which is on, basically this is a PCB that is inside here via I2C interface, and a few passive components that basically to interface with a coil here, because I've got 1, 2, 3, 4 coils, a bunch of passive component and some LED to indicate. You can see here there's absolutely nothing. This controller here, where is he now? Let's bring him back. So this guy here basically detects the presence of conductive element that is actually inside here. You see there, when I press, it goes inside. So there is a conductive element that enter a field. When you power this board, right, there will be a field that will be present here. Now, when I'm pressing there, I'm pushing a metal object, a conductive object, into an electromagnetic field. The IC here will then detect the change in the magnetic field by measuring the inductance that will be created. So these coil here already have an inductance, right? But when I press a button, the metallic object enter the field, it will change the characteristics of this field. Basically, it will change the inductance. So the IC here, the clever guy here, will then measure that change, and it will trigger an action by sending instruction to the controller inside here to do something. When a conductive target approaches a coil, eddy currents are induced in the target, right? And these then create a magnetic field that basically opposes the coil field itself, thus reducing its inductance. Now, this change in the inductance is then measured by the IQS9320 to determine the proximity or the presence of the target. So that's basically in a nutshell, but we should be able to do another tutorial where we're going to break it down, explain it more clearly by going through the mechanical characteristics of this button here. Okay, now enough of the talking. Let's just quickly demonstrate what's going on here. So normally I will be using a CT210 to test with a computer, basically to interface with a user interface with my evaluation kit, as I've done in the previous tutorial. But this module here basically makes life easier. I don't have to install any user interface, just my USB-C, right? And then my EV kit. I'm ready to start testing. So let's go connect the EV kit. So I'm just going to push it through. Remember, if you find this snippet useful, please make sure you give the thumbs up, share it, and subscribe to CMTEQ channel for more tutorial on Azoteq semiconductors. I mean, the LEDs are coming on, so these are these reverse mount LEDs that you see there. Let's put back the button. Great. So the first time you plug it in, you first need to calibrate it. So I'm going to press here to calibrate. Now I can press fully, all key. Okay, now the system is fully calibrated, okay, and ready to basically start processing the change in the magnetic field. So I'm going to stop, and now when I press, you can see it's detecting the channel 0, channel 1, as you can see there. There we go, channel 0, channel 1, channel 2, channel 3, okay? And then there is this button as well here. And then remember, there is a controller inside there that is also controlling that interface. Oops, I've pressed the calibration again. Now we need to calibrate again. Stop. There we go. So that's basically what I'm doing here. I'm just pressing the buttons there to test these inductive sensor IQS9320 by Azoteq Semiconductor. So next time we're going to basically open the PCB, break it out, and also go through the mechanical constructions of these buttons as I've already explained. When I press, there is a change in the magnetic field, and that change is measured by the inductive sensor, and that's how the actions are created and trigger points are sent to the controller and something happens. So stay tuned for the next tutorial or next snippet into Azoteq Semiconductors technologies. Until next time, cheers.